This diagram shows a standard Playwright snapshot shrinking from 56.2 kilobytes to 299 bytes. Over a session, that's 315 kilobytes down to 5.4. Without reduction, basic tool outputs consume limits. Pulling access logs fills memory, triggering compaction that aggressively deletes older data. The resulting bottleneck is severe. After just 30 minutes of coding, the agent loses 40% of its available context. It forgets files it was editing and abandons active tasks because initial instructions no longer exist. Context-Mode is an open-source model context protocol server designed to intercept and neutralize this exact exhaustion cycle. Extending a viable coding session from 30 minutes to 3 hours requires changing how an LLM receives local data. The current standard practice feeds raw data directly into the LLM, treating the model as a brute force data processor. Injecting megabytes of API responses or unstructured grep logs directly into the prompt displaces the cognitive space required for the model to actually analyze and solve the primary coding problem. The solution requires restricting the LLM to its strongest capability, acting strictly as a code generator rather than a document reader. This logic flow contrasts an agent counting functions across 50 files. On the left, it attempts to read all files directly into context. On the right, the agent generates a script instead. That script processes files locally, outputting only the final integer back. Shifting the AI from a passive reader to an active programmer is the necessary step to reclaim 98% of those wasted tokens. To enforce this shift, Context-Mode uses a strict subprocess sandbox to intercept data before it hits the prompt. When the agent uses the execute tool, the server spawns an isolated process capable of handling 12 different programming runtimes, including Python, Rust, and TypeScript. If the agent writes JavaScript or TypeScript, the system automatically detects the bun runtime, accelerating execution by 3 to 5 times. These generated scripts perform all of the heavy data analysis entirely within this isolated local boundary. The sandbox enforces a hard physical rule. Raw data, like full log files or complete API payloads, cannot cross back over to the LLM. Looking at this diagram, you can see the boundary wall blocking large data packets entirely. The only thing permitted to pass through to the context window is the final standard output string from the executed script. While the sandbox successfully blocks context bloat, it creates an immediate problem. The AI might actually need granular details from that hidden data to perform complex analysis later in the session. When a tool outputs more than 5 kilobytes of data, the agent needs a way to reference that information without loading it all at once. Context-Mode solves this using its index tool, which chunks the overflow data and routes it into a local SQLite database. This diagram shows those large data packets flowing into a central database, structured specifically as an FTS5 virtual table, optimized for high-speed full-text search. Instead of reading everything, the agent uses the search tool to run targeted queries, like the fragmented word authenticate seen here, using BM25 ranking to pull precise snippets. The search relies on a dual strategy. The first pathway, porter stemming, analyzes the query and matches it to root words and exact terminology, like authentication. Simultaneously, the second pathway uses trigram substring algorithms to actively scan and match partial, fragmented string data.
These two parallel paths are then mathematically merged through reciprocal rank fusion, ensuring the system outputs only the single most relevant code snippet back to the agent. By combining isolated sandboxing with deterministic FTS5 retrieval, Context-Mode replaces a degrading, passive memory with an active, on-demand query engine. Eventually, even with these optimizations, a long-running agent workflow will hit its hard token limit, triggering a total context compaction. This compaction acts as a forced amnesia. The agent instantly drops older messages, forgetting pending tasks, open files, and the specific rules the user established at the start of the session. To defeat this amnesia, Context-Mode relies on its final technical pillar, hook-driven continuity. The system deploys background interceptors, specifically pre-tool use, post-tool use, and user prompt submit, that constantly monitor the session.
Post tool use silently tracks every file edit and syntax error, while user prompt submit logs the critical corrections and architectural preferences dictated by the developer. Right before the amnesia event actually occurs, the server triggers a rescue operation via the pre-compact hook. Relying on the AI to organically remember its complex state does not scale. That state must be deterministically captured and stored at the system level to survive the limits of the context window. As the context window collapses, the pre-compact hook takes that captured state and builds a highly structured session guide. This diagram illustrates the extreme constraint on that guide. It is strictly limited to a 2 kilobyte budget. The snapshot operates on a priority tiering logic. High priority blocks, like active files, unresolved errors, and Git operations, are always forced into this 8th state. Conversely, low priority metrics, such as MCP tool call counts, are actively dropped if the budget becomes too tight. Once the agent clears out its older memory, the session start hook steps in to complete the loop, injecting this 2 kilobyte snapshot back into the model. This rehydration process restores the agent's working state, allowing it to instantly resume complex debugging or feature building without the developer needing to write a single prompt to catch it up. If the agent needs more granular detail than the 2 kilobyte guide provides, it already has the full event history safely indexed and waiting in the FTS5 database. True session continuity ensures an agent never loses its exact place in the codebase, neutralizing the most severe bottleneck in autonomous software development. The Subprocess Sandbox, the FTS5 Retrieval engine, and hook-driven rehydration all work in tandem to consistently achieve a 98% reduction in context consumption. This architecture transforms what would normally be a degrading 30-minute chat into a stable 3-hour engineering session. Developers can verify this impact in real time using built-in utility commands. As shown in this terminal view, you can pull up a direct read of your token savings and session efficiency right inside your IDE. For enterprise environments, the security implications are straightforward. All SQLite databases operate completely local first. Raw tool data never leaves the host machine, and the open-source Context-Mode Server contains 0 telemetry. These databases act strictly as ephemeral memory for the agent, automatically expiring and clearing out when the project session concludes. Check the Context-Mode repository to integrate this architecture across 15 supported platforms, including Claude Code and Cursor, and permanently secure your agentic workflow.